Hello, in this video we will look at the Additive Synthesizer project from my book, Sound of Music Projects for Eurorack and Beyond. And this is another fun project to build on a solderless breadboard. We've got 4 rotary encoders here with built-in push buttons and also an OLED display. And of course that user interface is described in one of the chapters in the book and forms the foundation for some of the explorations in synthesis, including this additive synthesizer. In terms of configuration, I'm using just a plain TNC4 without an audio shield today, just to demonstrate the use of the TNC as an audio device. And so if we take a look in the integrated development environment, go under Tools, you'll see that I have a TNC4 selected, and we want to make sure that the USB type is set to audio, or in this case MIDI and audio, since we're routing MIDI from a digital audio workstation to the TNC, and the TNC is functioning as an audio device. And I have a digital audio workstation, in this case Ableton, running, but this experiment should work with any DAW, including some of the free ones that are available. So if we take a look now at the settings of the DAW, you'll see that I have the TNC configured as an audio output. And just to underscore what a powerful feature that is, by making a simple selection on the menu in terms of assigning that TNC board as an audio device, and it's ready to go to be uploaded with some code and to function natively with other software and devices, including in this case Ableton Live. So I find this is a really convenient way to prototype, and I can listen to the output as I normally would in a DAW, and then as I finalize projects, then design custom circuitry or use the audio shield that's also available from PJRC. And of course I talk about that in great detail in the book. So the purpose today is just to get a feel for the additive synthesizer. And I'll put on my headphones and let's take a listen. So if I play a note, you'll hear the individual sine waves. There are 4 of them oscillating at varying rates. And so to go through the various screens here, we could alter the multiplier. This is the frequency offset. And so for example, with the multiplier 2, if I happen to play A440, it would, the first harmonic or partial would be 880 as an example. So let's take a listen to an alteration of the first overtone. Okay, there's another screen where we can alter the LFO rate. So for example, let's increase the rate. You can hear that changing the timbre of the sound. Let's go back and take a look at the first, or rather the 4th harmonic. And if we're to alter that rate, you can hear the changes in color. Another screen is the amplitude of each of those components. So we can bring out that top partial, and let's reduce the second one. And then finally there is an amplitude for each of the modulators. And let's change the octave. For this particular synth, that's the one I think that sounds really cool, are these slowly oscillating tones. So the AddiSynth project represents one potential approach to additive synthesis. And in this project, we're using 4 sine waves, and each of those sine waves can be at different amplitudes and frequencies, of course. And one of the unique things about this particular project is that each of those sine waves can also be modulated with a low frequency oscillator. And so I really personally like the potential of this project to create some really interesting soundscapes, those kind of slowly evolving sounds that can be very evocative, especially in the lower register. So pretty easy to build and code, following the concepts from my book, Sound and Music Projects for Eurorack and Beyond. And also with the power of the Teensy Audio library, really makes the coding quite reasonable for this project. So I hope you enjoyed the video and will have a chance to explore with some of these concepts on your own.